So guys, we are going to continue the discussion with respect to statistics. And in our previous session, we have already seen about the introduction to probability. And we had seen addition rule specifically for mutual exclusive event and non-mutual exclusive event. Now in this topic, in this session, we are going to discuss about multiplication rule. And this will be specifically for independent and dependent events. So let's first of all understand what are independent events. So if I talk about independent events, I can basically write two events are independent, two events are independent, right? If they do not affect one another. Okay. Now let's take one example. Okay. Suppose if I take an example of tossing a coin, and when I'm tossing a coin, suppose I get for the first time heads and then tails, right? Now during this particular scenario, what will be the probability of head during the first time? It will be almost same, right? 1 by 2. After that, even though after tossing the coin as head, and then if I toss tail also, it is not going to impact the probability of tails, right? That time also my probability of tail will be 1 by 2 only, right? So this specifically is like independent. These events are actually independent. Once, suppose in the first toss I get a head, and then if I try to get a tail, the probability is not going to change. Similarly, if I take another example, rolling a dice. Now in this particular case also, if I say that, what is the probability of getting 1 and then getting 2, right? At that point of time also, this will be considered as an independent event because probability of getting 1 will not affect probability of getting 2, right? All the time, probability of 1 or probability of 2, they will be having the same probability, that is 1 by 6, right? So this is one specific example. Now if I consider dependent events, suppose if I have a dependent events, and I'll give you a very good example with respect to this too. Now what is dependent events? Two events are dependent, right? If and only if they affect each other. They affect each other, right? Now let's see. Suppose I give you a task. First of all, you draw you take out a king's. Take a king card from the deck and then the queen card from the deck, and then the queen card from the deck. Now just think over it, guys. Will this become a dependent event or not? Obviously this is going to become a dependent event because initially the total number of cards, right? How much it will be? 52. Now suppose my task is that during the first take I take out a card and probably I get king, and then after that what is the probability of taking out the queen card? So initially, suppose if I take out the card as king, then what will be my probability? It will be 1 by 52. Sorry, not 1 by 52, 4 by 52, because there are 4 kings. Now suppose if I take out the king card and do not put back inside the deck, then what will be the probability of queen after taking out the king's card? After taking it out, I have taken out one card which is of king. Then what will be the probability of q? Then this will be 4 by 51 because one card has already been taken out. So this kind of event is called as a dependent events, right? So if I talk about the multiplication rule, so let me just write down the formula for multiplication rule, and let's take the same example. First one is for an independent event. Independent event. So suppose if I say what is the probability of taking out, let's take the same example, that is tossing a coin. Now suppose if my question is that what is the probability of getting a heads and then getting a tail? At that point of time, this multiplication rule for an independent event becomes something like this: probability of h multiplied by probability of tail. So what is probability of h? 1 by 2 multiplied by 1 by 2, which is nothing but 1 by 4. Now in this case, since the events are independent, right? Since the events are completely independent, it is not going to affect the probability. In the additive rule, we used to use OR, right? In multiplication rule, we use it as AND. Now what will happen in the case of dependent event? The formula will change little bit more. Dependent event. Now suppose I am given a task that what is the probability when I take out a card from the deck? What is the probability of first of all getting K? And then if I take out one more card, what is the probability of taking out Q? That is Queen's card. Let's consider this. In this particular case, my formula will become something like this. Probability of K multiplied by, remember this is a dependent event. Once if I take out the K card, the remaining number of cards will be 51, right? So the probability will change somewhere here, right? So in this particular case, I will say probability of K or probability of Q given K, right? Because I'm trying to find out probability of Q and I have already removed the K card, right? So this particular formula is also called as Bayes theorem. So this is like the idea towards Bayes theorem. There's a machine learning algorithm in Naive Bayes, right? We will be using this kind of formula there also. So that is the reason why I'm actually teaching you about this dependent event. Later on, when you learn about the Naive Bayes theorem in machine learning, you'll be seeing this. This is also called as conditional probability. Conditional probability. So if I go ahead and calculate this, what is the probability of K? Because the total number of cards in the deck is 52. So here you will be having 4 by 52 multiplied by 4 by 51 because I have not put the K card back. After I remove the K, then there is going to be some impact if I'm trying to take out Q to find out that specific event. So this will be my total probability when I have this kind of dependent events. And this is what is called as conditional probability. A very, very important topic. Probably in most of the interviews also they have basically asked. So this is nothing but it is a multiplication rule with respect to independent and dependent events. A very important thing in terms of probability to really understand, right? So I hope you have understood this. These things we have learnt in the school days, guys. You should definitely be able to recall it. In the case of independent event, this is how my formula will look like. In the case of dependent event, this is how my formula will look like. And this conditional probability will also be used in Naive Bayes machine learning algorithm. So I hope you have understood this. If not, please do make sure that you revise the video. Overall, in this particular video, we have covered all the topics: introduction, additional rule for mutual exclusive event, non-mutual exclusive event, and similarly we have done it for multiplication rule in the case of independent and dependent events, right? So yes, I'll continue the session, and in the upcoming videos we are going to discuss about permutation and combination. Thank you.